The largest flying animal ever, and how it stayed. Airborne. Imagine standing on an open plain. The ground begins to tremble underfoot, dust rising in waves with each heavy step. And then a shadow passes over you. Not a plane, not a bird, not anything you've ever seen, but a creature the size of a giraffe, gliding silently through the sky. This was Quetzalcoatlus northropi, the largest flying animal that ever lived. Its sheer scale is almost impossible to comprehend. Wings so vast they stretched nearly 40 feet from tip to tip. Legs so long that when it stood, it towered over most other animals around it. And yet, despite its monstrous size, it could take to the air and soar for hours, covering miles without apparent effort. The very idea of an animal like this challenges everything we thought we knew about flight, evolution, and the limits of life on Earth. Quetzalcoatlus lived at the very end of the age of dinosaurs, in a world that was changing fast. Forests gave way to open plains, coastlines shifted, and rivers carved new channels through the landscape. Most animals that evolved flight had to follow strict rules: be small, be light, be compact, constantly cheat gravity at every moment. Birds had mastered the art of sustained flight. Bats, later, would perfect maneuverability. But Quetzalcoatlus shattered all preconceptions. Its discovery baffled scientists because it seemed impossible that an animal of such scale could ever take off. Hollow bones, thin-walled yet reinforced like a series of natural engineering marvels, allowed it to support incredible weight while keeping overall mass low. Every feature of its body was designed with precision. Nothing was bulky without purpose. And yet, even with all of this evolutionary engineering, the most fundamental question remained: how did something this large ever leave the ground? Its habitat played a critical role in answering that question. The late Cretaceous plains of North America were warmer than today, with stronger, more predictable air currents. Wind gradients, rising thermals, and open expanses created ideal conditions for soaring. Unlike most birds, Quetzalcoatlus didn't rely on constant flapping to stay aloft. Instead, it exploited environmental forces to minimize energy expenditure. The launch itself was a spectacle of biomechanics. Using both powerful forelimbs and legs, Quetzalcoatlus performed a quadrupedal leap that propelled its massive body skyward. Unlike bipedal takeoffs, this method distributed force efficiently, reducing the strain on any single limb and allowing an animal of unimaginable size to overcome gravity in a single explosive motion. Once airborne, its wings, long and rigid, acted as nearly perfect gliders. By adjusting posture and subtle wing movements, it could harness wind currents to stay aloft for hours, even days, covering vast distances in search of food or mates without flapping continuously. Its lifestyle was likely a mixture of hunting, scavenging, and opportunistic feeding. With a long, pointed beak, Quetzalcoatlus could snatch small vertebrates, fish, and even insects, striking from above with a precision that would make modern raptors envious. Some paleontologists suggest that it also fed like storks or herons, wading in shallow waters or along riverbanks, grabbing prey in a calculated, energy-efficient manner. Its enormous wingspan was not just for show, it allowed it to glide silently, stalking prey from high above without detection. And because it could launch from flat ground with such explosive power, it didn't require cliffs or elevated platforms to hunt, unlike many modern soaring birds. The combination of anatomy, environmental awareness, and sheer size made Quetzalcoatlus an apex aerial predator, an unrivaled master of the skies. The energy efficiency of its flight is also remarkable. While modern large birds like albatrosses and condors rely on long-distance thermals, Quetzalcoatlus could do the same at a scale almost unimaginable. Its hollow bones and lightweight skeleton meant less energy spent lifting weight, while enormous wing area allowed for maximum lift with minimal movement. Scientists modeling its flight estimate that it could glide hundreds of kilometers in a single journey, effectively allowing it to patrol massive territories in search of food or mates. Unlike most predators constrained by the size of their home range, Quetzalcoatlus could expand across landscapes, monitoring rivers, floodplains, and open forests with ease. Its presence likely shaped the behavior of numerous prey species, creating ripple effects through ecosystems that we are only beginning to appreciate. Despite its terrifying scale, Quetzalcoatlus was also an animal of balance. It wasn't built for speed or aerial combat. It wasn't chasing other flying animals like some predatory birds do today. Instead, it mastered patience and efficiency by soaring high while waiting for the perfect thermal lift and observing from above. It turned flight into a low-energy hunting and traveling strategy. Its enormous wings acted like sails, and its hollow but reinforced skeleton ensured structural integrity during long flights. It was a creature that turned the constraints of physics into an advantage, partnering with gravity rather than fighting it, using the natural forces of the atmosphere to extend its reach far beyond what any other animal could manage. The ecological implications of an animal this size are staggering. Standing as tall as a giraffe and with a wingspan wider than a small airplane, Quetzalcoatlus likely influenced entire food webs. Its presence would have forced prey species to adapt in novel ways, whether by hiding more effectively, migrating differently, or developing new strategies to avoid detection. Even smaller predators might have been indirectly affected, unable to compete with such a massive aerial presence. Quetzalcoatlus wasn't just a predator. It was an ecosystem engineer in the air, shaping the evolutionary pressures of late Cretaceous plains in ways that we can only begin to imagine. Its sheer scale also raises questions about reproduction and social behavior. Launching such a massive body repeatedly requires enormous energy, and juvenile Quetzalcoatlus likely had to grow under very specific conditions to reach adult size. Nesting strategies may have involved open plains or secluded cliffside areas to protect eggs and hatchlings from both terrestrial and aerial threats. Adults would have needed vast territories to support their energy requirements, and the ability to soar efficiently over hundreds of kilometers would have been essential to maintaining these territories. The combination of soaring efficiency, hunting strategy, and reproductive needs paints a picture of a sophisticated, highly adapted animal that was both a marvel of biology and an evolutionary experiment at the edge of what physics would allow. Quetzalcoatlus wasn't just large, it was a master of aerial strategy. Its enormous wingspan, nearly 40 feet from tip to tip, allowed it to exploit wind currents and thermals with precision. Unlike smaller flying animals, it didn't need to flap constantly. Instead, it could ride rising columns of warm air and glide for hours, covering enormous distances with almost no effort. This efficiency meant it could patrol massive territories, searching for food, water, or nesting grounds without exhausting itself. In a sense, the animal turned the sky into both a hunting ground and a highway, expanding its influence across the late Cretaceous landscape in ways that no other predator could. Its hunting techniques were likely as sophisticated as its flight mechanics. With a long, pointed beak and keen eyesight, Quetzalcoatlus could spot small dinosaurs, reptiles, and even fish from hundreds of feet above the ground. Rather than chasing prey in a high-speed dive, it could swoop silently and strike with surgical precision, relying on patience and observation rather than brute force. Some paleontologists suggest it may have hunted similarly to modern storks or herons, wading through shallow water or stalking small animals along the edge of rivers and lakes, ready to grab anything that came within reach. Its enormous wings gave it the ability to hover or glide just above the water or ground, making it both a versatile predator and a formidable presence that shaped prey behavior in its ecosystem. The mechanics of its quadrupedal launch were another marvel of evolution. By using all four limbs to vault into the air, Quetzalcoatlus generated explosive force that allowed its enormous body to lift off without the need for cliffs or elevated platforms. This method also minimized stress on individual limbs, reducing the risk of injury while supporting an animal many times heavier than any modern bird. Once airborne, the long, rigid wings locked into perfect airfoils, allowing for gliding with minimal energy expenditure. This combination of explosive takeoff and sustained soaring meant that Quetzalcoatlus could cover tens or even hundreds of kilometers in a single journey, surveying its territory, tracking prey, or migrating to different feeding grounds as needed. The ecological implications of its size and range are profound. Quetzalcoatlus would have influenced not only the species it preyed upon, but also the behavior of other terrestrial and aerial predators. Smaller pterosaurs or carnivorous dinosaurs would have been forced to adapt their hunting strategies or avoid certain areas entirely. Its presence alone could alter prey distribution, forcing herbivores to change feeding habits, migrate differently, or evolve heightened awareness of aerial threats. In this sense, Quetzalcoatlus functioned not only as a predator, but as a shaping force in its ecosystem. A true apex aerial engineer that left a mark on the structure of late Cretaceous communities. Reproduction and growth likely posed unique challenges for such a massive flyer. Juvenile Quetzalcoatlus would have required abundant food and ideal conditions to grow to adult size, while developing the musculature and skeletal adaptations necessary for flight. Nesting behavior may have involved secluded areas, elevated cliffs, or open plains, where eggs and hatchlings could avoid terrestrial and aerial predators. Adults may have traveled long distances to find suitable nesting sites or sufficient food for growing young, highlighting the importance of efficient flight for survival and reproductive success. Every aspect of its life, from feeding to reproduction to migration, was intertwined with its ability to master the air. The sheer scale of Quetzalcoatlus also redefined what it meant to be airborne. Its shadow alone could instill instinctive fear in smaller animals on the ground, signaling danger long before it ever struck. This passive influence on its environment was a form of silent dominance, an invisible hand shaping the behavior, movement, and distribution of countless species. Even other large predators had to account for its presence, knowing that a sudden glide overhead could intercept prey or disrupt their hunting grounds. In many ways, Quetzalcoatlus ruled not through confrontation, but through inevitability. Its combination of size, precision, and efficiency made it an apex predator in 3 dimensions. It commanded the air, or influenced the land, and controlled the interactions of life below it. Every aspect of its existence, flight mechanics, feeding strategy, reproductive behavior, and environmental impact, was a masterclass in evolutionary engineering, proving that sometimes the most powerful predator isn't the one that bites hardest, but the one that can dominate without ever touching its prey. Finally, Quetzalcoatlus stands as a testament to the ingenuity of evolution. Its hollow bones, reinforced skeleton, massive wings, and specialized takeoff mechanics represent a perfect adaptation to its environment. By partnering with natural forces like thermals and wind currents, it turned what should have been physical limits into an advantage, achieving a level of dominance in the air that no other animal has matched. Its disappearance at the end of the Cretaceous reminds us that even the most perfect adaptations cannot withstand massive ecological change. Quetzalcoatlus didn't just exist, it conquered the sky, reshaping its world through flight, strategy, and sheer presence, leaving behind a legacy that continues to astonish paleontologists and inspire imaginations today. Finally, Quetzalcoatlus represents a reminder of the power of environmental adaptation. Its enormous size, hollow bones, specialized launch technique, and soaring abilities were all finely tuned to the conditions of the late Cretaceous. Changes in climate, air density, and prey availability would have challenged its dominance, and ultimately, as ecosystems shifted and the age of dinosaurs ended, these giants disappeared from the skies. Their fossils are rare, but each discovery gives us insight into the limits of flight, the genius of natural design, and the incredible diversity of life that once ruled the Earth. Quetzalcoatlus didn't just fly, it mastered the physics of the world around it, turning the impossible into reality and holding dominion over skies that no other animal could hope to claim.